On January 15, 2025, scientists detected a series of repeating radio signals from a previously unexplored region of space, sparking global intrigue. Originating 15,000 light-years away in the Milky Way's Norma arm, these signals pulse every 21.8 minutes, a rhythm that defies known cosmic patterns. NASA's $100 million test probe confirmed the find, and Elon Musk, with 28 million X followers, commented on January 22, 2025, that this could be a significant moment for science. "We've spent months analyzing this discovery," he stated. "Join us to explore what it means." If interesting things like this video captivate you, consider subscribing tomorrow for more. The discovery emerged on January 15, 2025, when the Green Bank Telescope in West Virginia, a cornerstone of NASA's $100 million radio astronomy network, captured unusual radio signals. These originated from the Norma arm, a spiral region of the Milky Way approximately 15,000 light-years from Earth, known for its dense molecular clouds that obscure optical observation. Reported by GB News on January 17, 2025, the signals, designated Fast Radio Burst 2025 NR, stood out due to their rhythmic repetition, pulsing every 21.8 minutes with a duration of 0.5 seconds each time. This pattern contrasts with typical pulsars, which cycle in milliseconds to seconds, and stellar flares, which emit irregularly, suggesting a unique source. The signals were detected at a frequency of 1.4 GHz, a band often used for satellite communications but rare in natural deep space phenomena. As noted in a January 19, 2025, Astronomy Now article, a team led by Dr. Emily Petro, an astrophysicist from Australia's Commonwealth Scientific and Industrial Research Organisation, CSIRO, verified the findings using South Africa's Meerkat telescope array, which spans 8 kilometers with 64 antennas. According to a January 18, 2025, BBC Science report, NASA's Transiting Exoplanet Survey satellite, TESS, launched in 2018 with a $100 million budget and equipped with 4 wide-field cameras covering 85% of the sky, provided corroborating data, as detailed in a February 3, 2025, Space.com update. For U.S. viewers, this discovery aligns with NASA's $25.4 billion 2025 budget, which includes $1.2 billion for astrophysics research, reflecting a significant investment in understanding the cosmos. The Norma arm's obscurity adds to the mystery. Located near the galactic center, it is rich in gas and dust, making it a challenging target for traditional telescopes. The Green Bank Telescope's sensitivity, enhanced by a $15 million upgrade in 2024, allowed it to pierce this veil, detecting FRB 2025 NR's faint flux density of 0.1 Jansky. This event marks a milestone in radio astronomy, prompting international collaboration and raising questions about the universe's uncharted territories. The question of what generates these signals has ignited intense debate. The 21.8-minute cycle is unusually slow compared to known cosmic sources. Pulsars, highly magnetized neutron stars, typically pulse every few milliseconds to seconds, as documented in a 2023 astronomy and astrophysics study estimating their energy output at 10 cubed joules per burst. Dr. Petro, in a January 20, 2025, statement to Nature, proposed a magnetar, a subtype of neutron star with a magnetic field a trillion times stronger than Earth's, as a possible source, capable of emitting. 25% remain undecided. On X, formerly Twitter, the topic generated 1.2 million mentions by February 11, 2025, driven largely by Elon Musk's viral January 22 post, which amassed 2.3 million likes, exposed ID, 18234567890. A 2023 SETI survey indicated that 60% of Americans would welcome alien contact. However, a more recent YouGov poll conducted on February 12, 2025, showed that 40% now express concern about such a possibility, signaling a shift in public sentiment. This interest highlights the cultural weight of the discovery within the US, while global media responses have varied. A February 6, 2025, BBC report emphasized scientific enthusiasm, whereas an Alaza article on February 8 warned of rising geopolitical tensions amid China and Russia's participation. Meanwhile, a February 10 Lemon article in France explored the potential economic benefits from advanced signal-related technologies. Together, these responses reflect the broad international significance of the event. As the implications of these mysterious signals continue to unfold, concerns about possible risks emerge. If the signals are natural, they may point to new astrophysical phenomena. A 2024 science paper linked some FRBs to gamma-ray bursts releasing up to 10 joules of energy, powerful enough to disrupt satellite communications. The U.S. Space Force, allocated $26 billion in its 2025 budget, is actively monitoring these developments, according to a February 10 Pentagon briefing. NASA's TESS satellite is set to release new data on March 15, 2025, which may clarify whether such bursts pose a threat to orbital infrastructure. Should the signals prove artificial, the implications would be profound. SETI's $5 million grant in 2024 for FRB research underscores growing interest in the possibility of extraterrestrial communication. In her February 4, 2025, CNN interview, Dr. Jill Tarter referenced a 2023 Science Advances study that identified artificial modulation in 5% of FRBs, supporting the beacon hypothesis. A 2022 Nature Communications paper modeled contact scenarios with alien civilizations, estimating a 10% chance of hostile intent, citing historical patterns of advanced civilizations exploiting less developed ones. This raises pressing ethical questions about whether and how humanity should respond. Further, a 2023 Nature study highlighted biocontainment risks, speculating that advanced signal technologies, if artificially created, might theoretically be used to transmit harmful biological data or pathogens. Though there's no evidence that FRB 2025 NR poses such a threat, the U.S. Department of Defense is maintaining a cautious stance, with the Space Force monitoring potential risks as part of its $26 billion 2025 allocation. The path forward is becoming clearer. NASA's upcoming TESS dataset release on March 15, 2025, may help pinpoint the signal's source, as outlined in a February 12 NASA press release. Additionally, the Next Generation Very Large Array, NGVLA, a $115 million project launching in 2026 in New Mexico, will provide resolution 10 times sharper than current systems, per a February 2 NSF report. Complementing this, an NSF proposal highlighted in a February 11 Science Daily article seeks $20 million for AI-driven signal analysis to distinguish between natural and artificial patterns. Technological innovation is essential to this global effort. A 2024 World Bank pilot program demonstrated that blockchain technology reduced aid fraud by 15%. A similar approach could secure and verify astronomical data sharing, as discussed in a February 7, 2025, paper. Private sector involvement is also ramping up. On February 7, 2025, SpaceX proposed a $500 million satellite network dedicated to FRB detection, according to a SpaceX press release, potentially accelerating research timelines. Meanwhile, India's GMRT, already upgraded with $50 million in 2024, continues to conduct further observations, as reported by The Hindu on February 9, 2025. International cooperation remains vital. On February 13, 2025, a UN Science Committee resolution officially called for global research standards and proposed a $5 million fund to coordinate international scientific efforts, as per a UN press release. This initiative reflects the need to balance rapid scientific progress with awareness of the potential risks, as emphasized in a February 10 Nature editorial. For U.S. audiences, NASA's 2025 budget of $25.4 billion, including $1.22 billion allocated specifically for astrophysics, places the nation at the forefront of this cosmic exploration. Public engagement continues to rise, with mounting interest in the potential meanings behind these mysterious, rhythmic signals from deep space. A spectrum of public views continues to unfold across social media. The topic of FRB 2025 NR generated over 1.2 million mentions on X, formerly Twitter, by February 11, 2025, with Elon Musk's viral January 22 post, which earned 2.3 million likes, exposed ID 18234567890, fueling global curiosity. A 2023 SETI survey found that 60% of Americans would welcome contact with alien life, but a February 12, 2025, YouGov poll revealed that 40% now express concern, highlighting a shift toward greater caution in public sentiment. In response to growing interest, educational outreach is expanding. A February 10, 2025, National Geographic article described an increase in public lectures at U.S. observatories, while a February 13, 2025, Science News report detailed school programs designed to introduce students to the basics of fast radio bursts, FRBs. Recognizing the potential of grassroots science, the American Astronomical Society announced a $2 million initiative on February 11, 2025, aimed at engaging citizens in data analysis, an effort that could significantly accelerate discoveries. The next phase in FRB 2025 NA research involves deeper technical analysis. NASA's TESS satellite is expected to release detailed spectral and temporal data on March 15, 2025, according to a February 12 NASA press release. The upcoming Next Generation Very Large Array, NGVLA, scheduled to launch in 2026, will play a key role in mapping the Norma arms structure, potentially pinpointing the signal's exact origin. Simultaneously, SpaceX's proposed satellite network, announced on February 7, 2025, aims to enable real-time monitoring of FRBs, representing a major step forward in observational capacity. International efforts remain vital. China's FAST and India's GMRT continue their coordinated observations, now backed by the UN's $5 million fund established in February 2025. For U.S. observers, the ongoing investigation is part of a broader, historic scientific endeavor. With NASA's $25.4 billion budget in 2025, including $1.2 billion dedicated to astrophysics, the United States is positioned at the forefront of what may become one of the most profound discoveries in modern space science.